Okay, so now that we have everything set up and we're ready to go, we're going to be playing with some pretty crazy stuff here. So I am going to break down the program that we are writing. We're going to start off with our dependencies. So within the cargo toml, which is basically our dependency manager, we're going to be importing Pinger and Tokio. Pinger is going to be used for pinging hosts within our ping sweep in order to see if the hosts are up. Tokio is what we're going to be using for our concurrency or our multi-threaded capability so that we're able to ping and scan at the same time. Moving on over to our main or entry point for our program, we're importing functions and libraries for ping or pinger. We've got our sync MPSC here, our time for duration, our Tokio tasks, and our Tokio TCP string. So we start off by declaring a constant here for our common ports. And they're all going to be stored in basically a vector here. Constant port scanner. And then we move on over to an annotation for our Tokio main, which is our main function, but our main function here, or our main method, is actually going to be asynchronous. And this is where we begin with our pings. So our annotation there, or macro that instructs Tokio to run main function as asynchronous. That's where we're starting off here. Then we have async function main. And then our good old fashioned subnet being defined here. So we're only going to go with all of the IPs within the first octet here, and declaring the maximum number of hosts for our class C subnet, which is going to be 255. And we're just printing out using the print macro, saying that we're starting our ping sweep. And then we've got our for loop, which is going to loop through each possible host in the subnet. And then we're going to check and see if the host is up. So we're looking for a result from another function. And then if it's up and scan ports. So I'm just going to review again our key concepts here. So we've got our Tokio main macro, which is an annotation that marks main function as the entry point of the program. It runs the Tokio runtime under the hood so we can use asynchronous functionality, so the dot await. Some of the variables in here are subnet prefix, which defines the subnet to sweep 192.168.1.x. And the number of hosts of the subnet is identified as num hosts. So we've got our ping sweep and port scanning. So a for loop sweeps through the addresses in the subnet and performs the ping operation for ping host. If the host is online, so we get a response from our ping, it invokes port scanning. So the port scanning function, which is further down here, which are our scan open ports. Our ping host function here, that's the function that actually performs the ping operation on each host and sends the result back asynchronously using a dedicated thread. So we're going to use Tokio's spawn blocking to run the blocking ping function in a separate thread. And then we're going to create a channel to send the results. And then we're going to ping the host, which is this block here. And then if the host responds successfully, we're good to go. And then obviously send false if the ping failed, or if we have an error executing, it gives us an error message. Down here, we're waiting for the result. So the task spawn blocking, since pinger ping is blocking and it's asynchronous, we use the spawn blocking to run it as a separate thread. And we have to set channels for that. So the TX, so transmitter, and the RX, receiver, are used for passing the ping results from a thread back to the main asynchronous context. And then we handle that ping result. So in ping, we return a receiver stream, so the receiver ping result, where each ping result may indicate whether the ping succeeds, so pong means a response, or failed. We loop over each message for message in receiver. If we get a ping result pong, the ping was successful. The outcome is either true or false, so Boolean is sent back to the async context via the TX, or the transmission. Then we've got our port scan function here. So within this, we're spawning an asynchronous task to check each port in parallel. And then we're going to collect the task to await them later. And then down here, we await each port checking task. So the async tasks, we use the task spawn function, which is a part of Tokio, to spawn asynchronous tasks to scan each port individually and concurrently. Each task checks one port on the host and prints the result if the port is open. And we have our checking if the port is actually open function down here. So this function opens a TCP connection to the host's port. If a connection succeeds, the port is considered open. So in here, we formulate addresses to appear as such. So like 192.168.1.1 port 80. That's how it appears here within this formatting of the text. And then we try to connect the TCP port looking for a timeout. So if it's taking too long, we time it out in order to prevent hangs. Here, if it succeeded, the connection was successful. If it failed, there was a timeout that occurred. So TCP stream connect, which is a TCP connection, is attempting to connect to the host's IP and port using the Tokio async TCP stream. We're handling the timeout with timeout duration. So if connection attempt takes longer than 1 second, we consider the port closed. You'll notice we're using some data types in here as well. So we're using the string data type for our IP addresses and formatting. We've got bool, which is binary, true or false, 1 or 0, which returns types indicating whether or not a ping or port scan was successful. The U16 is an unsigned 16-bit integer that we're using for port numbers. And we've got our results type, or T and E. So that is a built-in type for handling success, so okay, or error, ERR cases. It's built into Rust. And then we also have our NPSC receiver and sender, which is used for sending and receiving ping results across threads. So our multi-producer single consumer function. So within the cargo toml, which we're using to define our dependencies such as pinger and Tokio, these are essential and required for pinging and asynchronous operations respectively. Our main function right here drives the program by iterating over subnets of IPs, pinging hosts, and then scanning for open ports on live hosts. The ping host function does the actual pinging in a separate thread since pinger is synchronous, communicating the results back to the asynchronous context. Now, port scanning, which is performed by scan open ports, is spawning concurrent tasks to effectively scan several ports at once. And then an asynchronous TCP connection determines if specific ports are open using Tokio's TCP string. So we're going to try to run it now. So cargo run. So as you can see here, I'm just going to increase our viewport. It's starting the ping suite for the subnet 192.168.1.0 all the way up to 255. Host 192.168.1.1 is up, so it's starting a port scan. Now it's scanning common ports on host 192.168.1.1. 443 is open and 80 is open, and then 25, 22, and 21 are closed. I'm going to use the Control-C to interrupt so that we don't have to sit there and wait for it to make it through the entire subnet. So for this specific program, we're using some very basic skills in order to create a port scanner.